Hello. Hello, Colin. Hello,
Hey,
Brandon. Hello.
morning, Professor.
Good morning. Good morning. Good morning. All right. Let us. Morning, Ryan. Morning, Xavier. Morning, Ariana. Oh, Ariana with the video. All right. Video killed.
Morning.
Good morning. Oh, and that's the voice, Judith. All right. Good morning. Excuse me. Good morning, Charlene with the double and the early. Good morning, Ryan with the double. Good morning, Michaela. Good morning, Adenelsi. Morning, Gaia with, did I just say with the double? Good morning, Anissa with the something. Good morning, Carolina. Good morning, Ariana. Good morning, Alexis. Got you, direct chat person about leaving early. Got you. Thank you for telling me. Okay. That's oh, Alexa says we got a full house. We all right. And Shayna. All right. Okay, so let's get this party started. And by party, I mean something. Um, okay. Sorry, I know what I will do if there's no question. Well, we're gonna yeah, I want to finish um doing at least the chunky central part of the midterm exam problem that we did yesterday. So that's what I'm going to go back to in a minute. The main thing is I want to show you, yeah, the central computation of the midterm problem that we were doing yesterday. Like I want to finish that. Um, and there's one other I'm looking forward to speaking about today, but I think, hang on one second. Well, yeah, but let me be clear that I really want to answer questions too, or I want to make sure that if there are any questions, I at least hear them. Again, the more specific the questions are, the more I can answer. If they're really big, like, can you go over all of problem blah, like, I mean, I could try, but then I can't do anything else type of thing. So what I'm trying to say is that first, just for continuity and clarity, I'm going to finish the other problem that we were just doing Monday because I don't want to leave, I don't want to rabbit hole. So I'm going to finish that problem. Then I'm going to stop uh, and see whatever questions there are. Um, who else? Hello, people that are, hello, Maria, and hello, whoever, hello. Okay, yeah. So I'm going to finish the problem that we were just doing yesterday, Monday. Then I'm going to stop and see whatever questions there are. The more, and again, the smaller or more specific questions, the more of them I can answer. I will also say that even if I can't answer all of them, just knowing what they are is helpful to both of us before I post this thing Friday. Like honestly, like even posting your concerns or whatever is helpful. Even if I can't like literally address them, it's good for me to know what's on your mind before Friday. And it's good for you to know that I know. Okay. So we'll do that right after I finish this problem. And let me, and then, and there's one other problem I'm going to talk about, but I can tell you right now in advance from past experience that as long as I finish this problem with you, and as long as I give you an opportunity to ask questions, then then if the questions take us for the rest of the period, that's super productive in its own way. But if there are, then I'll do the other problem. But either way, that's what the classes don't think that it's. You understand what I'm saying, I think. Good morning, Nasrin, if I didn't say. Good morning, Chanel, if I didn't say. All right, so I'm going to switch screens. Hold on. In fact, yeah. So I'm going back. I'm going to switch screens a couple times. I'm going back to this, but well, not this problem, this document. I'm going back to this thing again for what it's worth. The plan is like after questions or like the other thing I would like to say some things about today is this. I mean, that is my so that you know some things. I'm not going to say everything. Um, But this is where we are now. And again, so be thinking in the back of your mind, especially if all of this bores you, or if you're like totally clear on what I'm saying, you're like think like what your questions are. Um, okay, give me one more sec. So I'm gonna have to switch boards again. But where we were, well, yes, again, hold on, people coming, people. Oh, and there's something in the chat. I'm sorry. Hold on. And are we recording? And again, I'm sure I've said this 1,000 times, but I can't emphasize enough. Almost everything in this obviously I've given exams like this for a while, right? So almost anything in this exam, I mean, there is a video for it somewhere in the of my, I mean, you know what I'm saying? Like, put a little thought into it. If you go back to past semesters and I don't even know if search words work, and of course they do. Like, and if you look for like walkthrough, pre-MT walkthrough, MT, even writing problem 3 or whatever, almost somewhere in past semesters, I've talked about every one of these problems on some video or another. And you're welcome to go look for them, and please share them with other people. You're not in competition. Like literally, you are not. Like you could all get an A, and I would be. You get my point. So anyway, wait, someone's in the chat. Oh, yeah, yeah, yeah. Oh, okay, fine. So I've already gotten a question in the good, good. There's already a question in the chat. Again, I'm gonna like open it. I'm gonna stop and literally open it for questions as soon as I finish this problem. But there's already a question in the chat of can we go over how to solve the without a paddle? I understand the concept, but I can't figure out how to get the final answer. Well, yeah. So the answer is yeah. Like that is my plan. And if that's what most of you want to see or are concerned about, we're good because that's exactly what I will talk about after this. So yes, glad to hear my life has value. Okay. I'm not being sarcastic. So where we were, in my opinion, we had just done D3. And now the main issue of the whole problem is D sub 4. I don't know why it's called 3 and 4. It should be 1 and 2. It's just whatever. It's a typo. But to summarize D3, right? D3 is the pictorial representation of adding vectors tip to tail. And I'm drawing fast and spastically and all that. But again, to emphasize, if you draw that one carefully, and I want you to. I mean, that's part of this is like a presentation. It's definitely part of this exam. Like you have time you're doing a rough draft. So if you do that carefully, put the vectors like with a ruler and you put them tip to tail, then you're creating a check on your answer for the next piece that we're about to do. Like I want you to understand that drawing vectors tip to tail is not just a rough sketch. It is a computational tool. That's really the lesson of lab 3. So if your final vector of that triangle, if the vector that completes that triangle from D part D3 here, if your vector that completes that triangle is like, tilted to the northeast at a very steep angle and is very long, that's telling you that the answer that vector is the answer that you're looking for in D4, which is what we're now going to do. And I see the chat. We're going to now analytically get it, but the two things should be consistent. And that's okay. So if one's going northwest and one's going northeast, like something is wrong somewhere. So it's helpful to understand that. Okay, so I'm going to do it, but there's something in the chat. Sorry. Oh, wait. Okay. So there's an O in the chat, which is like deeply provocative. Like, oh, what? Like, oh, if that's an O, like something just clicked, or like you now understand something. I'm delighted to hear what it is because maybe it'll help other. Okay. Cause my life has value. If I'm about to say something that you guys need to hear, then my life has value. I'm not saying it doesn't otherwise, although that's a conversation. Okay, I'm gonna go. All right. So I'm gonna switch the screens. I'm gonna switch the screens and so bear with me. Actually, yeah, hold on. So we're about to do D4. Bear with me while I switch screens. And in fact, I'm just gonna please bear with. Oh, Lordy. Okay. Right, right. Okay. Um, two. Okay. So again, I'm doing. Oh, yeah. And in the interest, I hope this is clear too. In the interest of, oh, okay. So I'm gonna like do the physics right now. I'm not breaking it all down into steps and all that. Like that's your job. You still have to do that, but you could just take that, just take the physics that I'm showing you right now for this. Um, so the thing that we're looking for. Oh yeah, we started doing this yesterday. Yeah, yeah. Right. We're looking for the velocity of the water from the perspective of the boat, right? Like it doesn't matter what order the English is in. They could have said, what is the velocity? I'm looking at D. I'm looking at question D. It could have said, what velocity is the water moving relative to the boat? But instead it said, from the perspective of the boat, what velocity is what? It doesn't matter what order they put the English in. What matters is it's water to boat, right? We are looking for water relative to boat, right? That's what we're looking for. Now, there's various ways we can get it, but no matter what, we have to use GPR form number 5. Like we're going to add two vectors together or possibly subtract one from another. I mean, but we're going to use the addition of velocities um, statement and and I think at least the way I drew it yesterday, so I'm going to stay consistent with that right now. What I decided was I'm going to say, all right, if I need VWB, one way I could get it is VWS plus VSB, right? And I just know that's true, right? Because the pattern of the letters, like you want to get used to that. It's like AB plus BC equals AC, right? That doesn't mean I know all those letters. It means I know that statement is true. And there's others that I could have made anyway, but that's the one I think I was setting up yesterday, right? So now what do I do for the analytical method? I have to zoom in on each one individually. Why? So I can like resolve it into its components, break it up into an X and Y piece, resolve into components. I'm going to do that with each one individually. Right. So on the next page. So, and I can't see the chat. Bear with me for a second. Um, so here's first, zoom in on the first vector, VWS. Okay. So VWS, I was never specifically told the velocity of the water relative to the shore. I was told the velocity of the shore relative to the water. You follow? And right at the beginning of the problem, they asked me to make the inference. They were like, what is the velocity in part A? They said, what is the velocity of the water relative to the shore? I'm saying shore every time I read the word riverbank. They mean the same thing, and I'm changing the word in my mind because so that I have like three different letters to work with. Okay. So it literally asked me what's the velocity of the water relative to the shore? The very first question, right? That's an example where it wasn't trying to trick you. It was a fairly straightforward question. It didn't take a lot of work, but they're asking you because we need that information like now, right? So in other words, the velocity of the water relative to the shore was the opposite. This is that whole business that I wrote on the first page. This is the whole idea. I mean, if you were to write a GDP right now, and you already did for part A, this is the whole idea that the velocity of A relative to B must equal the opposite of V relative to A, right? Direction matters, right? So what I did was, so that means that the velocity of the shore, the velocity of the water relative to the shore was northwest, was 3. Now, even here, sorry, I recommend you have time. I recommend doing these arrows like with a ruler and like doing them to scale so you'll really see what's going on. Sorry, right. Okay. So I'm saying since shore to water was given as 3 meters per second at 45 degrees southeast, it seems to me that the opposite, water to shore is going 3 meters per second at 45 degrees northwest, right? So I'm zooming in on it. Now, why am I zooming in on it? Because I want to see what that means in the west direction and what that means in the north direction. Right, that's the key to this whole thing. And if I were you in your exam, somewhere around now or earlier, I would literally, as a GDP, like I'm not writing it down, but as a step 3 GDP, I would write Galileo's principle of relativity form number 4, which is every two-dimensional physics problem is in fact two one-dimensional physics problems occurring simultaneously yet independently. Like that's what's happening here. We're believing that going 3 meters per second to the northwest really means that you're going some amount west while you go some amount north. And then neither of the things that you're doing affects the other. That's what we're really saying. And the question is like, how much north and west? And oh, sorry, by the way, I'm sort of using informal language. When I say you're going some amount west or some amount north, I mean some amount of velocity. Like every arrow that I'm drawing, please understand, is how fast you're going at a point in space and time. Like this point right here is like you, or well, is the boat, whatever, is the object. And like these arrows are representing how fast in what direction it's going at that instant. They're not right? You see, that's why this is a little bit more abstract. They are not intervals through space. They are instantaneous um, quantities of motion for what it's worth. Okay, so I'm going to get each one of these. I'm going to say VWSX equals VWS cosine 40 because that horizontal line is adjacent to the angle. So so I'm doing SOHCAHTOA, but I'm doing right. In other words, VWSX equals 3 cosine 45, which is approximately 2.12 meters per second, right? Stop me if actually I can't. I'll look at the chat in a second. And similarly over here, VSY, same logic, equals approximate, and it's the same angle. I mean, it's a 45-degree angle, so that's not legible. Right? Also, pro tip, this is a subtle thing what I'm about to say. It's like it's like a total reward for paying attention to what I'm supposed to say. It's subtle. If you practice the step I'm doing now, right, is resolving the vector into its two components. Right. This is one of those things in physics, I promise you. It's very clear and easy once you practice it and once you do it, for most people. But it's deceptive. If you just watch me doing it, it looks a lot easier than it is. If you just watch me doing it, you need to practice it on your own, and I'll tell you specifically why. Because every time I break, do I want to write? when I took that white line and I broke it into an X and a Y, if you back up and try it on your own, you will see, and please do, you'll see there's actually many different ways I could have done that. Like I could have, and a lot of them won't work. Like I could have, if I just draw a line and I've never done this before, I might do something like this, for example. Okay. Now, the two things about that. First of all, those are not the right lines to draw. Right? But also, I might just think I got to turn this into a triangle and just do geometry. You must. This is it's not even a pro tip. Like it's a pro tip in the sense that here's where people lose points a lot. First of all, whenever you break apart these arrows, you've got to break them up into other arrows. Really, this is all about directions, vectors. You got to draw a bunch of triangles to do these kind of problems, and every one of your triangles has to be made up of arrows, not just raw lines. I promise you, that's one of the first things I look for, like in terms of like points or taking off points or whatever. Okay. And the arrows have to point in specific directions. So the second thing is we're literally saying that something that's going northeast means something that's going a certain amount east and a certain amount north. So like a lot of people, if you don't practice, will draw things like that or something. Now that is the same triangle geometrically, but then all of the directions are going to get fouled up, and it's going to foul up minus signs in your chart. I'm not trying to scare anybody, but I'm saying you want to practice this and make sure you're doing the correct resolution. How do you do the correct resolution? The pro tip that's really concrete, if you hear it, I'm sorry, I keep saying pro tip, it's so cheesy, but the advice, if you hear it, is that whenever you're breaking apart whenever you're breaking apart a vector, you treat it as the hypotenuse of its own right triangle. You're turning all vectors into their own right triangles, like an X and a Y axis, right? And when you turn a vector, when you treat a vector as its own hypotenuse, and then you are making the legs, what you should always do is draw the horizontal leg first. Always draw the horizontal leg first and draw it in the correct direction. Like if it's going west, draw it left. If it's drawing east, go right, or whatever your legend is, right? Draw it in a particular direction, and then from the tip of it, start the tail of the vertical arrow. Like that will never fail you. If you hear what I'm saying, notice there's many other things you could do that if you didn't hear that, or if you didn't practice like you would do, people do. What you want to do is always do two. We're saying that the legs add together to make the hypotenuse. It literally is its own mini addition. We're saying it's tip to tail. So you draw two vectors that are tip to tail. But my advice that I would never have thought of, like until a practice, is always draw the horizontal one first. You'll see why at the end, but just that's just what I'm saying. Okay. So I've done that here. I have a horizontal tip to tail with a vertical. I now have two legs. Now I leave it. That's one vector. Hold on. I'm switching screens like all over the place. Noted. Oh, wait. Sorry. There's a thing in the hat. Oh, wait, great. Okay, sorry. And someone just said noted. I'm wondering, oh, noted about my pro tip. I hope you mean. Thank you. Whoever just put note, I mean, I know who it is. The direct chat person who wrote it noted. I really appreciate that. That like helps me that good. And you should submit for points for that, honestly. I mean, it shows we're on the same page. But then someone else wrote in the direct chat, and I apologize. I'm like, because I'm going back and forth between looking at the test, whatever. Someone else wrote in the chat a really good question. I have an important question. Will y always be found with sine and x always be found with cosine? That is a huge and awesome question, particularly because the answer is no. And especially this will start really becoming a thing like in physics 204. I know people think that. It's very natural to think sine always goes with y, cosine always goes with x. No, it doesn't always. But here's what the always is. Cosine always goes with adjacent, and sine always goes with opposite. In fact, by the way, that's relevant for lab 5 and for the inclined plane and all that, which I maybe you're not quite up to, but you're about to be up to, like lab 5 and all that, those free body diagrams, which of course we haven't talked about here yet, but force diagrams, it's not always like y and x, but it always is that sine always, and that's not on this exam. I'm not trying to skip, but sine always goes with opposite. Cosine always goes with adjacent. And okay, and opposite, and everything we're talking about here, if you're doing this correctly, and I didn't understand this for a while, but everything is right triangles, not because the original vectors you're given. If you take the original vector, like yesterday's picture, this is a really good question. I am going to go on in a second, I promise, but this is like a classic question. The diagram that I drew yesterday, I made a big triangle and it was not a right triangle. It was a depiction of what was going on. What was going on was just what was going on. Okay. There was no right triangle in that. That's why that is one method of solving. That is not analytic. That is just a picture that, like, if you do it right, gives you the answer, but it doesn't allow you to do any analysis. When we do analysis, when we do the component method, we're deliberately taking every individual vector and breaking it up into its own right triangle. We're always going to have right triangles in this component method because x and y are axes are at right angles to each other. So every time you draw a little right triangle, whatever is opposite the angle takes the sine, and whatever is next to the angle takes the adjacent, and the hypotenuse is the hypotenuse. And one of the reasons I'm getting so excited by that question, if you always draw the x first, you will kind of ensure that your angle is measured relative to the x all the way throughout. If you always draw the x first, then you'll be keeping the angle measured relative to the x even by the time you get to the answer, I promise. And then that will mean, first of all, likely cosine will go with x. It's still not a guarantee, but likely it will. Certainly, what'll be clear is what is adjacent and what is opposite if you always draw the x first. And then will also be clear, you'll see in the end, that where the final angle is, because I know in my heart, I'm saying, no, it's opposite and it's adjacent. Believe me, I know that for half of us, we've always been confused. Like, I don't really know. Like, I know what they mean by opposite and I know what they mean by adjacent, but doesn't that depend which angle I pick? Yeah, good point. It does. But if you always draw the horizontal first, there won't be ambiguity about which angle to pick. So adjacent and opposite will be clear or clearer. So that's how you do it. It's SOHCAHTOA. I don't know if that's important. Right. Huh. Like someone's following up in the direct chat. Yeah. And I'm yelling because that's what I do. But this is a big thing for physics and physics students. Yes, I'm acknowledging this is a little jostling. I am saying, as far as which takes a cosine or a sine, we care about the x-axis and the y-axis. It's all going to matter in the end. But when you're drawing each one of these triangles, when you're deciding what takes a cosine and what takes a sine, literally, explicitly think of it as SOHCAHTOA. The opposite goes with the sine, and the adjacent goes with the cosine. And that's the rule. Now again, honestly, with these kind of problems on this exam, if you literally stick to the procedure I'm saying, it won't even be a conflict. I'm not trying to scare you. It's going to work out that 99% of the time, if not 100, the cosine will be on the x-axis if you sort of do it the way I'm saying. But when in doubt, your rule is cosine goes with adjacent. Okay? SOHCAHTOA is, if there's anything you ever learned in a math class that actually matters, but it's SOHCAHTOA. SOHCAHTOA is so real in physics and Pythagorean theorem. For real. Yeah. Okay, cool. Thank you. Someone said got it in the chat. That makes me very happy. That gives my life meaning. See above. Okay. All right. So we've done that. I've resolved one vector into, I love the excitement in the chat. Okay, cool. The exclamation points. All right. So I've resolved that vector. Now I go to the other. So now that's just that information is just sitting in my memory bank or whatever. Now I go to the other vector. So we zoom in on the other velocity vector. And what was that? I don't know. The other velocity vector that I needed velocity of of, we're doing water relative to boat. So we needed shore relative to boat for the other one, right? Right. And we weren't explicitly told it, but we were told, um, yeah, we were told the boat relative to the shore. And then we were asked in B to flip that in our minds to get the shore relative to the boat, right? In other words, the shore relative to the boat was 8 meters per second at 30 degrees southeast. Because like I flip, right? I mean, the original given was northwest, but I flipped that arrow. And this is all GPR form number 5. Everything I'm saying here, right? I mean, it's all right. Okay. It's all the this is all the mathematical implications of this of train of thought. And again, okay, so like I know the course is like there's a bunch of equations and like calculus, and then there's like this weird train of thought, like Yaverbam yelling about planet Earth. Like what? This is where it all comes together, or where it starts to, and it stays together for the rest of physics. Like they really are not too. You get my point. So, so you need to do both. That's why it's a physics class, not just a math class or whatever. So so VSB is 8 at 30 degrees southeast. So southeast looks like this, and it's like longer than the other one, right? So I'm making it longer than the other one, and it's like 30 degrees. Oh, and notice right there. Oh, and here's also, okay, wait, I'll finish drawing it, and then I'll, V equals 8. I mean, VSB equals 8 meters per second. And again, a little subtlety here. Notice the V with a arrow over it means the whole vector quantity. V with a arrow over it means velocity, like all the information, the speed and the direction. But then when I'm like breaking into triangles, like I'm saying that long line, the length of it representationally is 8. Like the speed, the size of that arrow is 8 meters per second, right? It's not an accident that I'm not putting an arrow over the V there. Anyway, that's a subtlety. But now, on your whole sine, cosine, XY thing, here is part of what I'm saying that, again, if you hear what I'm about to say, it will really help you. I promise it's not a sidebar. Like when I just even drew this arrow, like how did I even know where to put the 30 degrees? That's part of the issue for people. It's like I don't even like it looks easy when I do it, but then when you go to do it yourself, it's like, wait, I don't even I'm okay, so he drew the arrow, but like how did he even know where to put the 30? How did he know not to put it at the bottom? Or how did he know like here's how. When someone says southeast, what they or northwest or whatever, what they really mean. I mean, I would definitely write this in your notes if this is new information. Southeast is an abbreviation for south of east. That's really what it means. It means south of east. So when we say southeast, what we really mean is in our minds, we picture a reference axis that's pointing off to the east. And then we open an angle 30 degrees south of it. Like, first of all this assumes that somewhere on your page, and you should do this, somewhere before you start all this madness, you're making a diagram and you're defining a coordinate system. Now, I mean, typically they look something like this, but you define it any way you want as long as you're consistent. But notice I have north, south, east, and west. And I have positive and negative, like individually assigned to each independent axis, right? Positive and negative from the beginning of the semester is what we care about on a number line. Now we got more than one number line going on. Each one has its own positive and negative, right? Now, when I say 30 degrees southeast, what I mean is what I just said. I mean, picture an east and open up 30 degrees south of it. So this is part of why I emphasize so this is why you always draw the horizontals first, because as you're watching me, if you do that, and then in the end of the day, your angle will always be opened up, will always be almost automatically measured from a horizontal. And that's what you secretly want. You want if you're wondering which angle do I, if you're doing this, if you're translating back and forth from the English to the math and back correctly, your angle is always going to be measured from the horizontal because nobody in English ever says 30 degrees east north. Like if they did, that would mean the same thing as 60 degrees northeast, if you're following me. You want to keep this all consistent, so you measure the angles from the horizontal. And if you do that, and you always draw the horizontals first, then actually that question that two people were asking in the chat about like SOHCAHTOA, then everything checks on itself. Then there actually won't be a conflict. Your adjacents in this context will turn out to be horizontals, the x-axis. But I'm just saying, but don't like, you see what I'm saying? But southeast means south of east. That's how I knew to make the 30 degrees the way I did, because this angle is 30 degrees south of east. Okay, so I did that. Hopefully that I'm going to go back to that. Sorry, I'm switching screens. Okay. So I did that. So now I'm going to break it into components. So, I mean, I sort of already started. So I'm literally going to say, fine, it's some amount east. You see what I'm doing, right? It's some amount east plus some amount south. Now, even right there, you could have gone the other way, and people do. I could have gone south and then east, but don't, because then there's going to be confusion of whether I'm looking at a 30-degree angle or a 60-degree angle. I'm dead serious. This is why I'm calling this a pro tip. It's a strategy. Like, honestly, if you're all over the physics, there's different things you could do and compensate for yourself and make it. But if you want the most straightforward guarantee, southeast in my mind, A means south of east, and B, it means some amount east plus some amount south. I'm literally awkwardly always saying the horizontal thing first for this reason. Okay, so there's my triangle. So, and you see, it's three arrows, two arrows adding together to make the third. So then the top is VSBX equals, to cut to the chase, 8 cosine 30, because it's adjacent to the angle. And what is that? That's like 5 points. I don't know what it is. It's I should, but it's like yeah, okay, okay. It's like 6.92. 6.93, sorry. Meters per second. That's a speed, right? So I'm literally at that moment. If I'm going 8 meters per second at that moment at 30 degrees to the southeast, then really at that moment I'm going 6.93 meters per second to the east while I'm going. I don't like writing inside the triangles, but it is what it is. I ran out of room. 8 sine 30 here, which is exactly 4 meters, because the sine of 30 is a half, right? Okay, so now I have my two components. Okay, now that's like the hard work in a way. What do I do? So I'm literally saying, well, I'm saying these are the two velocities that have to be added together now. I did all that work so that I can add the two vectors that I'm needing to add. Okay. Like no addition has occurred yet. But now it can. How does the addition occur? It occurs independently along each axis. So I go, okay, I'm going to add up the VXs independently from the VYs. This will be, I forget already. Yeah, water, better be, yeah. Sorry, this would be, and this would be, and I'm going to add them together. Nope, sorry. Right? Like the whole idea is that VWS plus VSB equals VWB. How did I know which ones to add to get to the last one? Because of Galileo's principle, right? The whole idea is that my speed relative to the subway plus the speed of the subway relative to the streets equals my speed relative to the streets. That's the principle here. Okay, so I'm adding those two velocities, but I'm only adding them in one axis, like at a time. So I now take the numbers for, and I'm adding, like no matter what, like I'm adding. It doesn't matter if some of them are negative, but I'm adding. So, so now I look at the numbers from those triangles, like the first, okay, VSX was 2.12, right? But it's going to the west. I'm looking at the X component. It's going to the west. So in my coordinate system, that's a negative. So I literally put in negative 2.12, right? Then I look at the Y component of that, also 2.12 because the angle is 45 degrees, but it's going north. So that's a positive. So I put in like positive 2.12. See what I'm doing? And then, and I will look in the chat. And if you don't, this would be a good time to tell me. Then I look at the other vector. Okay, it's 6.93 to the east. That's positive. And it's 4.00 to the south, which is negative. So negative 4. Do you see what I'm doing? Wait, I'm looking at the chat. I'm assuming that you do. And now I literally just add, right? But I mean, taking into account the minus signs, and you see here why. I'm looking at the time. We're good. All right. Never say that. You see why you really, when you make these triangles, there have to be arrows in them. Like the moment where I'm taking into account direction is when I like look back at those arrows and see whether they're going left or right. Like right? If they're just triangles, I don't know. And then the minute I see whether they're going left or right or up or down or whatever, I mean, again, and you notice I look at it one at a time, like whether to put a negative sign or a positive sign only applies at one axis at a time, but it does apply. So if I didn't have arrows in those triangles, I wouldn't know where to put the negatives and positives in this chart. And so then literally the numbers are going to be like wrong in the end. If you don't, you see what I'm, anyway. So, all right, so now I literally add like 6.93 plus negative 2.12, which is the same, thing as, right. So I get like positive 4.81 there. And this, the same thing. I mean, not the same thing, but, okay, negative. Right? So now I'm looking at the chat. Now, what that means, I mean, in a way, I've done the addition now. What that literally means is from the perspective of the boat, if the boat is watching the water, what the boat sees the water do is every second the water goes every second the water goes 4.81 meters to the east, and every second it goes 1.88 meters to the south, right? I mean, if it keeps this up. I mean, really what it means is at this moment, what the boat sees the water doing is at this moment, it's going 4.81 meters per second to the east, and it's going 1.88 meters per second to the south at the same time. Like that's what this really means. I mean, that's what it means. But it is meaningful. It may be a lot to get used to, but it is describing the physical world. But now, but that's describing the physical world in two components separated. We want to put them back together. So we draw yet a third right triangle. And you'll know, I mean, I can't remember if it says it in the test or not. But sorry, in a problem like this, when you're adding velocity vectors, which is what this is, if you were to like look up videos of other, Khan or I'm not a paid advertiser, if you were to look up videos from like what you're talking about here is addition of velocity vectors. And whenever you are by component method, and whenever we're adding velocity vectors by component method, you'll know you're doing something right if you've drawn a total of at least 3 right triangles. And you're doing something wrong if you haven't. Like each vector gets its own right triangle. And then at the end of the day, we're going to take the information and put it back together in one big right triangle. Here's how I make the big right triangle. This is what you want to practice. I'm going to make a big right triangle now. I am watching the time. I'm going to make a big right triangle now that I honestly, if I don't practice, there's many ways to do this, but there's really one best way to do it. And the best way is to start with the X and draw an arrow according to the X. Like I'm going to draw a, 4.81 unit long arrow going positively, going to the east. So I'm going to draw like this, right? In other words, VWBX equals 4.81, right? And then from the tip of that, I'm going to start the tail of a arrow that is in the y-axis that's going 1.88 meters per second to the south because of the negative sign to the south, right? So it's something like this is my final. Do you see what like that's strict. Always do the X first from its tip to the tail of a Y. So I have this. Right. And I don't like have to put the negative signs in the triangle because first of all, like sides of triangles aren't negative like ever. But second of all, the negatives are explicit with the arrowheads. Like that's what they're doing. So now at the end of the day, the answer I want, the answer I've been looking for the whole time is this. Whatever the missing, right? Now, hopefully, I don't even have the guts to look back. I was going so fast yesterday and I'm such a spaz. What I want to assert to you is this blue thing that I'm about to look for really should match up in direction and approximate length to whatever I drew 2 days ago in part 3 when I put the things tip to tail. Now, in my case, maybe it didn't because my drawing might have been terrible. I don't want to look, but you are going to be careful and you want to look. And if the two are not similar, something is wrong somewhere. Okay. In my case, I know if they're not similar right now, what's wrong is my diagram from 2 days ago was too fast. I'm just saying that. Okay. But this is what I'm looking for. So the total VWB that I am looking for, the length of it will be Pythagorean theorem, the square root of 4.81 squared plus 1.88 squared. Sorry. Well, hello. Right now, I'm totally running out of room. So, well, I could do this on. Well, yeah, no, I'll keep this on this page. Right. So, what is that now? That's approximate. I mean, there's like square roots and everything, so it's not going to be. But I can tell you without even going in the calculator, I better get a number that's a little bit bigger than 4.81, but not 1.88 bigger than 4.81, right? Like if I get a number now, if I do the square root business and I get like 3 points, I think something's wrong. And also if I get like 6.81 or something, something's wrong. It's good. You see what like we're not adding numbers, we're vectorially adding numbers. You see what I'm saying? But I better get a number that's like sort of 5 point something. And your calculator for all this stuff, this class, your calculator should be in degree mode for all of this. A warning, physics 204, your calculator should always be in radian mode, but whatever. Like make sure your calculator's in degree mode for all this kind of thing. All right, so I get 5. Now that's meters per second, right? That's a speed. So I'm almost done. I'm almost done, but I'm saying that the velocity of the water relative to the boat, i.e., if you're in the boat and you're playing a video, like this is a video game, and you're the boat perspective, the first person perspective, and you're the boat, and you're like watching the world, you would see the water moving away from you at 5.16 meters per second at this moment. Like that's what we're saying, right? I can't put it any better than that. But now the question is in what direction? So what is it? Well, the angle that we want, this now circles back to the chat questions. Like what angle? Here's the deal. If you've been, the angle that you want, well, the angle that you want is this one. And I'm telling you that if you always draw your horizontals first, every single time when you're breaking up the vectors and when you're putting them back together. If you always draw the horizontal first and then make the vertical tip to tail with that, then what's always going to happen it's going to work out nicely for you that the angle that is measured relative to the horizontal will, at the end of the day, in fact, be the angle between the tails of the two vectors. And that is self-consistent. Like you'll again, if you're like still hanging with me here, if you are looking to choose your angle, if you see that the angle between the tails, well, let me back up. The angle between the tails is the angle that the boat is facing, if you really think about it. If you really understand that putting vectors tip to tail means adding them, then like this is the water. I mean, and that angle represents, that angle right there represents the angle that the water is facing from the perspective of the boat. Okay. And if you've done things correctly, that angle between the two tails, which is the angle that you're looking for, will be an angle measured from the horizontal. So that means you've done everything sort of right. And the answer you're going to get will make sense in English. In other words, I'm looking for that angle now. I'm going to do SOHCAHTOA again. I actually could do any SOHCAHTOA, but look, I've got an opposite side. I've got an adjacent side. So I'm going to say tangent. I'm always using tangent for this final step. You could do anything, but I think it's safest to use tangent. The tangent of the angle equals the opposite over the adjacent. So the angle itself that I'm looking for is the inverse tangent, right? Think about that. The tangent of the angle is one side over the other. I don't want the tangent of the angle. I want the angle. So I do inverse tangent of whatever my calculator tells me, or arctangent, tangent to the -1 of what? Of 1.88 over 4.81. And so the answer will, I hope, I don't know how to say it more. I mean, I do, but, so I do that on my calculator, and I better be in degree mode. All right, yeah. So I get approximately 21.3 degrees what? South of east. Because look at the picture. So my final answer and make this clear on your at the end of the day, what I'm saying is from the perspective of the boat, the water is going 5.16 meters per second at a direction of 21.3 degrees southeast. Like that's the answer to that part of the problem. Well, I'm looking at the time. Okay. And I mean, I'm not saying there isn't more to the whole problem, but that's the centerpiece of the problem. Honestly, like that's the point of the problem. And it's the hardest, thickest part of the problem, possibly the hardest, thickest. Computationally, that's like the thickest thing in the test. And it's also the newest material. So that's why I wanted to like walk through it as explicitly as I could. But that's like how you do that. And now when I give you your exam, on Friday, and when I post it, please, of course, understand, like, yeah, I'm going to change the numbers, maybe, and if I'm creative, maybe it won't be a boat and water and, it could be, maybe it'll be a subway and a this and a that, whatever. Don't be thrown. But somewhere in, and maybe I'll even ask the questions in a different order. But the point will be, you have 3 objects. I'll ask you a bunch of preliminary questions to get yourself oriented with the 3 objects. And then somewhere you're going to have to add the velocities of 2 of them in order to get like the velocity of one relative to another to get the velocity of the third. And it may be like, I'm going back, you'll do this. And if you can do it, you can do it. It'll be like this. What you'll do is just like this. But like what you'll add to what like the givens, I'm just saying, I will move on in a second. But like the givens here, I gave you shore relative to water. And then I gave you boat relative to shore. So like I gave you like a chain like that. It could be different on yours on Friday. Like maybe I would give you shore relative to water and boat relative to water. But you know how to arrange the things by always knowing VAB plus VBC equals VAC, no matter what A, B, and C are. Do you follow me? Like that's what you, okay, I think you get my point. So that's the main thing of there. I want to start. We have 20 minutes. Uh, E, well, yeah, I mean, I'll just say, well, E tells you exactly what it means that it's asking you to do. I'm not saying it's a joke, E, but what you definitely want is three different diagrams. Each one will have two vectors in it from the same perspective. Each one will have three vectors in it. Those will be drawn like tail to tail. You're not adding vectors there. You're just depicting two vectors, tail to tail. So you'll have three pictures, each with two vectors, tail to tail. And you'll know you've done it right. You'll know you've done it right if you want to check this and work out E with each other or in lab if you already had lab. You'll know you've done it right if you then complete the triangle for each one of them, like in your mind or with a dotted line or something, the three triangles should all be the same, just different rotations of each other. You'll know you've done it right. Where if at the end of the day, once you complete each triangle, you have the three identical triangles just in different orientations. That's all I can say about E. But all right, now we have like 70 minutes, which is plenty, honestly. I will at least give you an overview of how to do the without a paddle because someone already asked and it's what I wanted to do anyway. But I nonetheless want to pause and just say any questions you have, please put them in the chat now. I direct or not direct. I want to see all the questions and make a decision of like how many I can answer right now. And so I want to see all the questions, even if I can't answer them all right now. So put any questions you have or concerns or whatever in the chat, like please. And I'm going to pause for a second. I'm going to give you a moment. I mean, questions on this or questions on other. And again, if you just write solve problem 4, like we don't have time for that, but something specific, I'm going to pause so you can like leaf through the exam or let this sink in. And I promise you, we have time for, that's a good question. Sorry. And then after this, I'm going to like let you, you see the problem? So Colin's question, am I okay with you using 9.8 instead of 10? That's a really fair question because, okay, in the exam, if you use 9.8 instead of 10, of course, I'm not going to take off points. I mean, like, yes, that's accurate that I wouldn't mark it wrong if you put 9.8 instead of 10, but I got to say, I recommend that you use 10, especially in problems like the warm-up problems at the beginning, when all the numbers, if a lot of the numbers I'm giving are like divisible by 10, that is probably a hint that it'll be much easier for you to picture and compute and much easier for me to follow and check if you just round gravity to 10. Like it may be, in fact, that there's there's like insights or clues that you'll see much more easily if you round to 10. So I'm okay with you doing 9.8, but I gotta say, my strong I won't favor it more. I won't be more impressed, to be honest, if you do 9.8. If you do 10, honestly, I'll be more like we're on the same page in this class and we're in a communication. Like, and please don't think you're lying. If you put 10, it's not a condescending thing. Like, that's what physicists do, not in the lab. But that's what they do when they're working at theoretical problems because the 9.8 is already rounded anyway, really. So it's not like a lie or like it's not like a kindergarten-y thing to do. It's a sophisticated thing to anyway. So I'm okay with it, but I would strongly recommend that you keep lowercase g to 10. But also pro tip on that, as long as someone's asking. What I also want to say is yes, lowercase g is 9.8 or 10, whatever, and that's it. It's that number. Don't automatically assume it's negative. I know we said this Monday, so I won't rabbit hole, but don't automatically call it a negative number. Call it a number and then make independent decisions about your coordinate system and whether you're signing it positive or negative. But okay, that's it. Yeah. No, if you did 9.8, like I'm not going to mark it off, but you're not making your life or my life easier by making it 9.8. And literally those early problems on the first sheet, they work out much more nicely and reveal facts if you just use 10. But anyway, but yeah, it's okay. It's okay. I mean, it's a good question. I'm going to shut up for a second. Think about your questions. I also have to fix something in the board. Bear with me. I'm going to release the board for a second, I think. Stop the share. Okay. Hold on. So give me a second. But take it, like leaf through it, make sure, because this is our opportunity, right? To snow crab. All right. All right. I mean, I will do this problem in a second, and we will have time to do it. I would recommend question, but okay. All right. Well, that's cool. Okay. Uh, okay. So without a there's no. Okay, okay, okay. Let me read that. Hold on. Good. I'm glad. Oh, I'm glad. No, I am. Hold on. Um. Okay. Wait. Who is that? Oh. Okay. Someone got kicked out. Okay. Um. So the question is. The question is not sure if someone else. Would you? Oh, the Yaver bomber. Yeah, I mean that's fair. All right, let me see if I can say something fast about that. I mean, the main thing I want to, okay, I'll try to say something. So we've 10 minutes, 11 minutes. Let me see. And I'm going to warn you right now that for this next 10 minutes, I'm probably going to keep the board. I'm just going to talk, okay? Because I think it'll be more efficient. Yeah, I think it'll be more efficient. So as long as you pay attention or take notes, we'll do everything. But someone just asked about the Yaver bomber, which is yeah, sort of an awkward problem at times. But the main thing of the Yaver bomber problem is that it is lab 4. I mean, literally, it is a horizontal projectile. So the main thing of it is to know that the x-axis and the y-axis don't affect each other, and gravity exists in the y-axis but doesn't exist in the x-axis. Like, right? I mean, and really understand it really is lab 4 because something is moving along and then moving along horizontally and then drop something that is equivalent to you firing something horizontally if you understand relativity. But the person's asking about the very last part. Oh, yeah. Wait. What are you asking? The last paragraph is confusing my brain. Yeah. All right. I'm fair enough. All right. The main thing is that until the end of this problem, this problem is again very much about applying perspective to equations. So until the very last part, I'm talking about the Yaver bomber here. Oh, that's what I'll do. Okay, I'll switch the screen to that. Hold on, sorry. And I am watching the time. So until the very and someone's here. Until the very last part, you're sort of focusing in your mind on movies of individual bombs coming down from the plane to the ground. That like your math and everything is focusing on that. And any individual bomb would do just like the ball in lab 4 would do. Any individual bomb would be falling down at a gravitational free fall acceleration rate, but it's also moving forward while it falls down. So any individual bomb would go in like a parabola, in a curve on its way down. And I think just like Lab 4, right? And I think you understand that. And so that the bombs, like the first one will land over here, and then the plane's over here and drops the next one. So the next one lands ahead of it. Each bomb will land ahead by a certain amount of the last bomb. And that's what you're figuring out and stuff. And I'm trusting, okay? But it is true. The key thing is now, if you stand back, if you're in a control tower somewhere, and this has been going on for a while. So this plane is moving along and just keeps dropping bombs. If you just take a picture, a snapshot at any one moment of what's going on underneath the plane, okay, what you'll see is what I'm about to tell you the answer. Again, this is like the reward for paying attention. Okay, but you need to think it through and understand it and explain it. But here's the answer. Like if you were to take a picture of the bomb, of what's going on underneath the plane at any given moment, you'll see what you would see if you type into Google Images. If you type into Google Images something like B-52 bomber World War II or aerial photograph or whatever, something like that, what you'll see is a bunch of bombs underneath the plane in a vertical formation. This is the surprise, but it's not a surprise when you think through physics. Like you won't see the bombs like arranged in a diagonal line going back. You won't see the bombs in a diagonal line arranged going forward. You won't see them in a curve going forward. Like it's not like a movie of one bomb where one bomb goes like that. You will see all the bombs lined up pretty much, like not exactly, but pretty much in a vertical line, like just below the plane, because each one of those bombs keeps going forward at the same rate, even though it's falling. So bombs will be lower than one another, but they're all going forward at the same rate all the time with that plane. So you'll just see. So the point of what this is asking, and then I'm going to move on, is if you were to draw a photograph, a snapshot in time of what's going on beneath this plane, you would see a bunch of bombs in a vertical, in a straight line. And that's what you want to explain to me in the exam. Like, just think about that. I'm going to move on. But that is the answer. And that's what it's trying to get at. But if you understand how that's the case, then you get physics in a big way. Okay. But if you don't, like, text me or email me, but that's what I'm getting at there. Now, chat. Okay. Now we have 6 minutes to do the other. Oh, that's terrible. I'm sorry. Wait. Sorry. Oh, you get that. I'm sorry. Okay, wait. What did I say? Wait. Thrust downward precisely half. Where does it say that? It says that? I mean, I believe you, but the page. Okay. Okay, it's just, and I'm a little worried about it's. Oh, I'm sorry. Okay. Sorry. Yeah, I see. I'm just trying to figure out how to say this quickly. What that's all about, the fastest thing I can say about that is the flip side of everything I just said. Like another takeaway of all of this stuff from Lab 4 and this, what you all do want to understand, Lab 4 assumed, or the X and Y are really independent, i.e., that if you drop something to the ground while at the same time you thrust something else forward, right? Then they're both going to hit the ground at the same time. You couldn't do Lab 4 unless you were assuming or believing that. Now, again, you want to think that through. That is a surprise to a lot of people, but it's totally about X and Y being independent, that if you drop something and you throw something forward without an angle, they'll hit the ground at the same time. This question is trying to test do you really understand that, but it is messing with your head. It's saying, okay, but now what about if instead of dropping something while something else is thrust forward, if we didn't drop the thing, if we thrust it down with some initial velocity, then like which one's going to hit the ground at the same time? And the bottom line is if you pushed it down, then it's going down faster than the other one because the other one is in effect just being dropped. No matter how fast it's going forward, it's just being dropped vertically. So the one that was thrust down would hit the ground first. I mean, that's the overall sum of what I'm saying. And I apologize. I'm going to go on because I want to say at least something big about about this. Okay, here's the big point about this. This problem, if you, and I know we only have 3 minutes now. I'm going to trust that you've read the problem and you understand what the question is. As far as getting the answer, the the big key to this problem is if you observe this problem from the shore, then sure, you see a boat that goes up and then down a lot, and like you're missing a lot of information, and it's going up at some slow speed and then down at some fast speed if you're watching from the shore. So the recommendation is the problem is much simpler. If you solve the problem from the perspective of the water, that's the key insight here. Now, again, you're going to have to think about this through and explain a lot. But if you choose the frame of reference of the water to solve this problem, i.e., you pretend you're the bottle, like the bottle's just going along in the water, right? They're the same frame of reference. If you're the bottle watching what happens, listen to me carefully, please. If you're the bottle, what you see is a boat going up at some speed to some place, right? And for 20 minutes, right? And then you see the boat turn around and come back to you. If you're the bottle, you don't move. You see a boat going up and down, and sure, you see a bridge going up away from you, right? Like even faster than the boat. But right, I mean, you see land moving past you, but you're just the bottle. So you'll just see a boat go away from you and then come back to you. And the reason that's so important to be the bottle, from the bottle's perspective, the boat goes away and then comes back. From the bottle's perspective, the boat makes a round trip that is even Steven. It goes to some distance and then it comes back. Granted, the whole shore is moving while this happens, but but the bottle doesn't care. So the bottle will see a boat go away some distance and then come back the same distance according to the bottle. Why is that important? Because the other fact that's given in the problem is that relative to the water, the boat goes a certain speed upstream and then does the same speed relative to the water on the way back. Now, that's not the same speed relative to the shore. No way. It's going fast, right? But to the water, it tells you that it's the same speed both ways. So if it's a given distance up and a given distance back, according to the water, and a given speed up and the same speed back relative to the water, then if it took 20 minutes to go up, it's got to take 20 minutes to come back. From the perspective of the water, the whole thing is 40 minutes if you look at it from the perspective of the water. And during that 40 minutes, the bridge traveled from the perspective of the water, the bridge traveled up 1 mile from the perspective of the so from the perspective of the water, the bridge is going 1 mile in 40 minutes, i.e., 1.5 miles per hour. End of story. That's the answer. And it's 12:05. But you have to, right? You have to think through why that makes sense and why that's okay. And if that is the answer that you get from the perspective of the water, that would be the answer you'd get from the shore, but it would take a lot more calculations. And that's the power of physics. So that's okay. So good luck. I'll see you Monday or Wednesday, but I'll post Friday. You can ask me questions up until Friday, and then okay. And if you, sorry, we're done. Have a nice day. But last thing too, if you anticipate, you don't want to be late with this exam. I'm very loose about a lot of things, but not exams. If you anticipate any problem this weekend, if you anticipate a problem, reach out to me and we'll see what we can do. But you've got to reach out. If it just comes in late without a discussion, that's not good. And there will be point penalty. Okay. Bless Cork, bless America. If there's questions, I'm just turning off the recording, but if there's questions, oh yes. Thread is kind of crazy. Sorry. Okay. I'm stopping the share. I'm stopping the recording. I'm stopping the madness.